Hi, in this video I'm gonna be talking about a plugin which was written in MATLAB's platform. This plugin with the name of Abaqus 2D Model Creator V5 and above belongs to the International Institute of Earthquake Engineering and Seismology and supervised by Dr. Janha. The written of it takes me around 1 year. Finally, it was delivered to the Institute at the beginning of 2019. This plugin can model the linear and 2D underground structures in the Abaqus finite element software. With this application, we don't need any of the previous knowledge in the modeling, designing, running, and also extracting data fields. You can be able to create a soil structure model which is 2D, homogeneous, and also has linear behavior. As perceived, it encompasses interaction subject and also has an infinite medium acception for soil under the shear wave field of motion with vertical incident angle and regular mesh dimension. Then it runs automatically, and finally the relevant graphs are achieved in a frequency domain. It should be mentioned that the verification of the models and output responses carried out similar to my thesis which I defended in 2016. The ISI paper is under preparation. These steps should be taken. First step, the user should make sure that Abaqus and MATLAB were already installed on the computer. Then the Pre-Process tab clicked. All the blank spaces should fill with the appropriate values. As you can see, some simple sample shown in the gray boxes. For obtaining the better results, you can read the instruction which are displayed when clicking on Help button. These parameters define characteristics, tunnels, geometry, and mesh dimension of the finite element model. Multi-block panels control the shape of tunnel. So, with a click on Yes, you can see this part unfreeze and this part freeze. And you have to insert the number of edges and the coordinates of them respectively. With a click on Auto Mesh radio button, the user allows the software to set the best mesh dimension to the model by itself. This value will adjust based on the highest quality of the output results instead of run speed. For this aim, it uses the theories and equations which are presented in this paper. With a click on Yes, in Rigid panel, the lining of the tunnel will be modeled with a rigid body. Therefore, just a rigid displacement of the cross-section can be extracted. It means U1, U2, and UR3 components. Otherwise, the software will provide the 3D and 2D graphs relative to the shear, axial, and moment forces. By clicking on Create Model, the process to create it begins. As you can see, the model created correctly. Well, after finish this part, we are allowed to go to next tab, process. In this section, the required parameters of the created model for the automatic run are introduced. In this section, as you can see, there are help buttons for giving more information. The number of the CPUs and the version of the Abaqus introduced in this panel. The numbers should be inserted in them. In the Find Location of Abaqus panels, the location of the installed Abaqus introduced. This work can be done in two ways, either automatically or manually. By clicking on the Manual Radio button, the user should insert the name of the drive that Abaqus located. We click on Automatic one. In the next panel, the runs condition shows online to the user. So, because the runs hasn't begun yet, the ready word shows in this part. This indicator also illustrates the runs condition by the colors. By clicking on the Abaqus Run button, the process will begin. Therefore, a panel for helping the current situation and indicators color is opening immediately. It must be added that if during the run process some errors occurred, they would be displayed completely in this panel. Now we are waiting for completion of the run process. It will be seen that at the end of the process, this part will be frozen to avoid a possibility of user faults. If the user needs to unfreeze, has to go back to the last tab and creates a new model again. As you can see, this model finished after this time. And the indicator and this status bar showed. Finally, we should click the Post-Process tab. In this tab, we can extract data from Abaqus software and then process and show them in the frequency domain. For achieving this purpose, firstly, the Extract Data is pressed. Then, by use of this graph, the maximum acceptable time which relates to the output data can be selected and should be inserted in this field. We choose 0.8. As you can see, the 0.9 second is the application default time. After that, in this panel, the type of output graphs which is favorable should be chosen. Finally, by selecting the ideal structural member, the structural strains in the frequency domain will be drawn. You can put a label on it. Finished. In the end, I must add all of my disease graphs can be drawn by this app, like this one. Thank you so much. Bye bye.